Hello, my name is Tomctutor, that's me. Sorry if I'm looking down here, I'm looking at my whiteboard behind me and I'm looking at the camera and I'm looking at different things, okay, my notes, etc. So if it looks a bit weird the way I'm doing this, I apologise. Just concentrate on the board, not me. Anyway, I'd like to cover today differentiation of inverse functions. This is part of my advanced higher video collection on YouTube, but this is also applicable to undergraduate and the GCE, A level and other various courses, so it's pretty generic. Okay, what do we mean by the inverse function? Well, if I've got a function of x, call it f of x, and y would be the y coordinate if I plotted this x to the x coordinate. So it's a single variable function. A classic example, of course, is the arc sine of x. Okay, sometimes called the inverse sine. X must be in radians, of course, because this is calculus, so we use radians in general. So my question is, well, what is dy dx? Or we can write that as f dash of x, of course, Leibniz Newton notation. Well, there's various ways you could work this out, but I'm going to do it in a formal method so we can look at any inverse function to work this out. Notice that I've written the function as the inverse function. So what I have not written is, I don't want to confuse you, but what I have not written is that if f of x is equal to sine of x, then we let g of x, some other function, equal to f minus 1 of x, is equal to the arc sine of x. I could have approached the problem that way. So now we have two versions of this general problem. One is the function is the arc sine, and the other way of working it out, if you like, is that the function is the function itself, sort of thing, not the inverse. So just be careful that you're quite clear what category you're solving the problem. But in here I'm stating quite clearly that the function is the arc sine. So let's try and solve this. So there is, if f of x is equal to that, then we see that the sine of y must be equal to x. By definition, if you like. Now, I can differentiate this thing, which I'm going to call g of y. Okay? I can differentiate that as a function of y. I can differentiate it with respect to y or with respect to x. If I differentiate that with respect to y, it's called g dash y. Okay, because y is the independent variable, if you like. But I'm not going to do that. I'm going to differentiate it with respect to x. Remember, y is a function of x. So dgy dx is equal to dgy over dy multiplied by dy over dx. And of course that's just the chain rule here. So we're using the chain rule, of course. So let's look at this. What is the differential of a sine y with respect to y? So I shall write it in here. Sine y dy multiplied by dy over dx, but dy dx is what we're actually trying to find here. It's actually f dash of x is dy over dx. Okay, so when I'm working out this problem, this trick, if you like, of creating yet another function here to solve the problem is really the heart of how you do these problems. You're given the problem as f of x, but I've created another function, if you like, trying to solve it. So that's an important concept here that you might be glossed over and you might not recognise. Anyway, we can see here that if I differentiate this with respect to x, the right hand side, I should put it there, it's just going to be dx over dx, which is just 1, of course. So that implies that what we have here is this is equal to 1, okay? So d sine y, of course, is just cosine y multiplied by f dash of x, which is equal to 1. So f dash of x is just equal to 1 over cosine y. Or is equal to, 1, the reciprocal of g dash y. Okay? Because cos y is this thing here. GG, that looks like my y's look like g's, apologise. So where are we here? Well, that basically is my answer. So f dash of x is 1 over g dash of y. But not quite, because x is a variable here, and I've got this in terms of y. So I have to express this guy as a function of x, not as a function of y. So, how do I do that? Well, it depends on the problem. Here I can see that sine y is x, so cos y is of course the square root of 1 minus sine squared y by the identity. Therefore, my f dash of x is equal to 1 over the square root of 1, and this sine y is just x, so here in this case we solved the problem. So that is how we differentiate an inverse function by method 1. Okay, where we're told that the function is given by that. So it's what you must remember is the differential in this way is just 1 over the inverse of that whole thing, which is just the function itself, but I differentiate it with respect to y. So the best way to start the problem is to write it out, define what f of x is, and that's very important, and then to define another function which would return x there, and that then would allow you to get the answer. Okay, I'll give another example in video 2 of this just for practice. Thank you.